Hello there, Mr. Sutton bringing you the IM 2-3 Honors 3-4 homework on similarity. For number 1, we just need to solve this proportion. We can do that by cross-multiplying. So we'll have 5 times x, 5x, equals 4 times 15, which is 60. Dividing by 5, we've got x equals 12. For number 2, we need to solve this proportion. We're going to cross-multiply to start this one off, but we have to be careful. This z plus 2, you need to distribute the 12 to both of these numbers. So we'll have 12z plus 24 equals 4 times 27, or 108. Subtracting 24, that gives us 84. And 84 divided by 12 is going to give us 7. For number 3, they want us to find the value of x in these similar triangles. So for this one, we're going to have to set up a proportion with corresponding sides. One of many combinations that would work. If we do 12 over x, that's going to be the same ratio as 6 over 4. Cross-multiplying, that'll be 6x equals 48. And dividing by 6, we have x equals 8. For number 4, we're given these two similar triangles, and we need to find the value of x. So because the triangles are similar, all of their length measurements are similar, including these altitudes. They will also be in proportion. So we'll set up a proportion. We can say that x over 28 is the same ratio as 30 over 35. And then we'll just solve by cross-multiplying. So we've got 35x equals, let's see, what's 28 times 30? I'll consult the calculator for this. That's going to come out to 840. So now we need to do 840 divided by 35. Calculator again. So I'll just divide my last answer by 35, and I get 24. On number 5, we have two similar triangles, and we have to find two variables, m and n. Let's start with m. So we can say that 5.5 over here over m is going to be the same ratio as 6 over 12. Or you could say m over 5.5 is the same as 12 over 6. Now, how do we know that 12 and 6 go together? Well, they're across from congruent angles. We have this angle, which is congruent to this angle. So in similar triangles, the sides that are proportional are across from the same angles. Cross-multiplying then, 5.5 times 12, that would be, let's see here, 66. And that's going to equal 6m cross-multiplying the other way. So we have m equals 11. All right, we'll do the same thing to figure out the value of n. We can say that 8 over n is the same ratio as 12 over 6. Cross-multiplying, we've got 12n and 48. So dividing by 12, n equals 4. For number 6, we're going to use this diagram in which JKLM is similar to EFGH. For part A, they want us to figure out the scale factor of this larger quadrilateral to the smaller one. So for that, we just need to find two corresponding sides and figure out the reduced ratio of those. So we need to figure out two sides to go together. It's a little trickier on this one because they're not oriented the same way. This larger shape is actually this smaller one rotated about 90 degrees. If you're not sure which sides go together, you can always consult the similarity statement. We see here that JK, the first two letters of that one, must be going with EF, the first two letters of the other shape. So JK and EF here go together. And we want the scale factor of the larger to the smaller. So we can do 20 over 8. That's, again, just JK over EF. 20 over 8 is going to reduce to 5 over 2. Which you could write as a fraction or a ratio. For part B of number 6, we want to find the values of x, y, and z. We already have the scale factor from part A. Remember, that was 5 over 2. So we can use that when we set up a lot of our proportions here. So for x, this x side corresponds with the 11 side over here. KL goes with FG because they're in the same position in those statements. So we can then say that x over 11 is the same ratio as 5 over 2. That was our scale factor again. Cross-multiplying, we've got 55 equals 2x. Dividing by 2, we have 27.5. All right, let's figure out y. So y is in the smaller shape, and that corresponds with this 30 side. So we can say 30 over y equals our scale factor of 5 over 2. So then that would be, let's see, 60 equals 5y, so y equals 12. And for the last one, z, this is the angle here. Now looking at our similarity statement, angle E, that's the first letter, that's got to be congruent to angle J. Looking at our picture, J is 65, so E also has to be 65. So this z degrees is really 65 degrees because it's the same as angle J. For number 7, we're given these two figures and a similarity statement, and we want to find the scale factor of the figure on the left to the figure on the right, and then the perimeter of each polygon. So let's start with the scale factor. So for that, you just need to take two sides that go together from each shape and reduce the ratio of those sides. Well, the only side we have from the smaller shape is this ST side, which is 21. Looking at our similarity statement, we see that since that's the first two letters of the first shape, it has to go with the first two letters, XY, of the second shape over here. So that's going to be 35. And if you look at this, this shape is really just this other shape rotated a little bit on its side. So these definitely look like they're also the same shape. So I'll write my scale factor then as 21 over 35, which I will now reduce by 7s to 3 over 5. Next, let's find the perimeter of each shape. We'll start with the perimeter of the shape we have the most information about, this second shape here. Adding up all those sides, we've got 20 and 20 is 40, and the 35 and the 25 here add up to 60, so 40 and 60 gives us a total of 100. Next, I'm going to let P represent the perimeter of this smaller shape here. So I can then write P over 100, smaller over bigger, equals 3 over 5, my scale factor from the smaller to the larger shape. Cross multiplying, I've got 5p equals 300, so then p equals 60. For number 8, we're given 3 triangles for the price of 1 here, and we're told that all 3 triangles that we see are similar. And then they're just rehashing the measurements that we see in the diagram. Long and short of it, we want to find x, this small side of the smaller triangle. All right, so we need to set up a proportion with x in it. We can say that the ratio of x to 12, the small side of the small triangle to the small side of the second biggest triangle, that's going to be the same as 12 to 18. 12 is the second longest side of that small triangle, and 18 is the second longest side of the second biggest triangle. So we have x over 12, x over 12, and then 12 over 18. Cross multiplying, we've got 18x equals 144. And then by calculator or by hand, we've got 144 divided by 18, so x equals 8 inches. Choice C. For number 9, we're trying to find the length of side AB here, represented as x. The key on this one is realizing that since we have these parallel sides, these two triangles, the small triangle and the bigger triangle, are going to be similar. And also, this side, this side, this side, this side, these little segments of the bigger triangle are going to be proportional. So you can actually set up a proportion with things written pretty much the way they appear in the diagram. We can say 14 over 12 equals x over 18. Cross multiplying, we got 12x and whatever 14 times 18 is. So doing that on the calculator, that comes out to 252. And then dividing 252 by 12, that will give me, survey says, 21. All right, we'll take the calculator's word for it on this one. So x equals 21. Now, if you just check your answer here, 21 to 18, that reduces, if you made it a fraction, to, what, 7 over 6, just like 14 over 12. For number 10, Community Park has a rectangular swimming pool enclosed by a rectangular fence for sunbathing. The shape of the pool is similar to the shape of the fence. The pool is 30 feet wide, the fence is 50 feet wide, and 100 feet long. Part A, what's the scale factor of the pool to the fence? Well, we only have one side that they both have, and that is the width. They told us the pool was 30 feet wide and the fence was 50 feet wide, so we'll do a ratio between 30 and 50. So 30 over 50, that's going to reduce to 3 over 5. Next, the length of the pool. So we have the length of the fence is 100 feet. So we need to set up a ratio with the length of that and the pool. We have the scale factor of 3 over 5. We can write 3 over 5 equals, and I'll just use x for the length of the pool, so x over 100. We have pool measurements up here. We have fence measurements down here. So cross multiplying, we've got 5x equals 300, so x equals 60. And this is a real life problem, so let's do units, so that'll be 60 feet. For number 11, we're purchasing a scale model of the Golden Gate Bridge from San Francisco. The model states that the scale is 1 inch for every 50 feet. The actual length of the bridge is 8,980 feet. Wow, I didn't know it was that long. Well, we want to know the length of the model. So we're going to solve this setting up a proportion. We've got 1 inch over 50 feet in one fraction, and in the other fraction we'll have the unknown inches on top and this 8,980 feet on the bottom. All right, well, let's go ahead and cross multiply. So we have 50x equals 8,980. Just got to divide by 50 now. Let's use the calculator. So going ahead and doing that division, we've got 179.6, and that's going to be inches. For part B, we're told the model's approximately 15 inches tall. We want the actual height of the bridge. So we can set this up with another proportion. We have 15 inches over an unknown number of feet equaling 1 inch over 50 feet. So we'll cross multiply again. 50 times 15, that's going to be 750. And 1 times x is x. Oh, so hey, x equals 750 feet. Nice.